Okay, we're back, we're live, we're here. ThinkTech Talks. We're here on a given Monday at 11 a.m., a little early. We are going to talk today about sending messages into space with Jon Lomberg, who is the project director of the One Earth message. And if you want to know more about that, I will mention this again. Look at oneearthmessage.org. So we're sending messages into space right here from Hawaii, and we want to find out how that happens, when that happens, what enables it, and who's supposed to get it. This is really interesting. So Jon, tell us who you are.
My name is Jon Lomberg. My wife and I live over on the Big Island in Honaunau, and I'm an artist who specializes in science, especially astronomy. I've worked with many of the observatories on the Big Island, and my work is probably best known for my 25 years of collaboration with Carl Sagan on virtually all of his projects, the original Cosmos series, the movie Contact, and the relevant project for this discussion, the Voyager Golden Record back in 1977.
So with Sagan, did you do the graphics for him?
Yeah. I like to think that we had a kind of Gilbert and Sullivan collaboration. We could do things together that neither of us could do individually. I was able to give visual form to his ideas, and he understood. He was pretty media savvy, and he understood that for a lot of people, visuals are much more effective than numbers at communicating things. So that was my role.
So you were the media half of the team, so to speak.
He was pretty media savvy as well, but I was the visual half, I would say.
Okay, the visual half, yeah. And so, I mean, did you have training in science, or is the training, I guess the training is by way of what you did with him?
For me, the training was the work with him. I'd always been interested in science and astronomy, and as an artist, I found, you should pardon the pun, myself gravitating towards that subject matter. And when he saw my work, he thought that we had the makings of a good partnership. But in any particular project we did, whether it was the Viking landing on Mars or communication with extraterrestrials, I had to learn the science from him because in a way, it's like being a medical illustrator. You can't make up the anatomy. So you either have to be a doctor or you have to work with a doctor to make sure that it's not only visually appealing, but accurate.
How do you make an astronomical graphic that's accurate? How do you do that?
Well, it's hard because half of the things are too faint to see and the other half are too bright to look at. So there's always an element of artist's license, you might say. And as in any other art, especially art about nature, and another good analogy might be the artists who accompanied Captain Cook and people like that, you wanted to show something to somebody who would never see the real thing in a way that they would understand it. And sometimes a picture is clearer than a photograph would be.
Sure.
So, for example, when an astronomer on one of the Mauna Kea observatories finds something and they want to have a press release, they want to have an image of it, I'll have to work with that astronomer to what does it look like? Is that too big? Is that too blue? Is that too bright? And we go back and forth until he says, yeah, I think that gives a good impression of it.
What medium or media do you work with in order to create the graphics? And are computers involved in that?
I started as a traditional painter with traditional media, but then
Is it oils or acrylics or what?
For me, mostly acrylics and pen and ink and watercolor on paper and canvas. Then I started getting into museum display design and working with Carl, book design and then special effects and graphics. During my career, I saw the introduction of computers that gradually replaced most of the conventional media. So I've sort of had to learn. But at the same time, I've also tried to keep a foot in painting. One of my friends and neighbors was the late Herb Kane on the Big Island, and we actually did a canvas together, a portrait of the Earth that was a joint project. So I've never lost my love for the traditional painting as well as the computer graphics.
So the Big Island, is there a reason you're on the Big Island? I mean, a scientific reason or a professional reason?
Both personal and professional. I love the oceans, I love scuba diving, I love astronomy, and since I've lived here, I've gotten more knowledgeable about the traditional Hawaiian and Polynesian astronomy and wayfinding, and find that that notion is so resonant with the current exploration of space. In fact, the exploration of the Pacific by canoe is probably the thing that's most like what our future in space may be like.
Interesting. Why is that? What's the common denominator?
It's hard to do. You leave one little point in an ocean and you try to arrive at another little point in an ocean, whether it's an ocean of water or an ocean of space. Ideally, in the future, we'll have colonizing voyages where we'll make human settlements on other planets, and that might be like the difficulty of establishing settlements on other islands. In a way, building the voyaging canoe for the Polynesians was very much like the space program for us. It required every bit of technology and savvy that they had, and it all came together in the canoe in much the same way that everything in our technology comes together in the space program is kind of the limit of what we can do now.
You have to use your best stuff out there. What about all the telescopes on the top of Mauna Kea? Do you have any contact with, do you work with any of the telescope companies up there?
Yes, I've worked with Gemini, with the Keck, with Subaru, and right now on the current project, one of our advisors is the director of the Canada-France-Hawaii telescope, and so we're working with them.
Don't forget TMT. I hope you can get in with those guys. That's going to be a really big one.
A really big one, long term. You know, it's going to be a while before it's open, but when it is, it should be fabulous.
Yeah, that's a 30-meter telescope we're talking, TMT. Okay, well, you know, you mentioned that the Voyager had some kind of messaging back in 1977. Tell us about that.
Well, the Voyager spacecraft, there were two of them, were sent out to explore the outer solar system. But they just keep on going. They'll never come back to Earth. They'll just drift in space forever unless somebody else finds them. And in case that were to happen 1 million or 10 million or 100 million years from now, the spacecraft will tell a lot about our technology, but Carl Sagan and Frank Drake, astronomers very interested in communicating with extraterrestrials, said we should put something on it that tells something about us. And what it ended up being was a phonograph record, not a laser disc or a digital disc, but an old-fashioned phonograph record, but made out of metal, on which we recorded music, speech, sounds, and about 120 images showing what the Earth was like. And that's become quite well known. It was launched in '77, and I don't think there's been a month or even a week that's gone by where I haven't read about or heard about some reaction to this project. It was, I think, thrilling for people to imagine that we were making a self-portrait of ourselves that someday might be read and seen by extraterrestrials.
Like a time capsule.
Like a time capsule, and we don't know if it'll ever be found, and if it is found, will they ever be able to figure it out. But there's a second audience, and that's us, the people on Earth who hear about these projects. And the record has been something that's inspired people. More than one scientist has told me that their interest in science began with hearing about this project. And it's been something that's given a perspective. Carl called it the cosmic perspective, that lifts us out of our squabbles, our rivalries.
And we need that.
And we need anything that makes us realize that we're one species, we're one ohana, in one little island in space.
Yeah. Okay, so what was I suppose it's still happening today with the Voyagers. That record is still there.
The record is still there.
Playing.
It's not playing. It's not active. It's just sitting there waiting to be played.
Point. Yeah.
But it's in a box, and I drew the cover illustration on the box along with Frank Drake, the smart guy who figured out how to put signals onto the record. And the cover of the record shows how you take a cartridge and stylus, which we've helpfully included. You put it on the record. You turn the record.
Instructions.
Instructions on how to play it. Yeah.
So if extraterrestrials should find this, then they will have this kind of graphic set of instructions on how to play it and see what's on there.
It took me maybe an afternoon to draw out this design, and the lifetime of it is considered to be 1,000 million years.
Meaning lifetime, meaning?
Meaning how long it takes for the occasional impact by a dust grain to wear away the surface of the box and eat through into the record.
And thus destroy it.
And destroy the side A of the record.
Yeah.
Another billion years to get through the side B where all the pictures are. And some of the music and sounds. So it's not often an artist gets a chance to make something, you know, that eternal, virtually
It is
eternal
virtually
from human
eternal,
points of
yeah.
view. And that's one of the captivating things about the project, that even if it's never found, that something of us is going to perhaps outlive our planet.
Yeah, yeah. So what speed does it play at? 33 1/3?
No, to double the amount of information, we played it at 16 2/3, which
Okay.
sacrifices a little bit of fidelity, but allowed us to put twice as much material on.
So did you articulate that in the graphic, the instructions? Or is it a player? Is the box a player?
No, they have to figure out what speed, but we've given the speed in units that we think another extraterrestrial physicist would understand. The whole question with these messages is, how do you talk to some alien creature? What do you have in common? And the answer has been thought to be that what we have in common is the physical universe. The laws of physics, the periodic table, Newton's laws of gravity, Einstein's laws, they're the same everywhere. So if we start trying to talk about those things that we share, mathematics might be another example. What's a prime number? That's the same everywhere. So that's how we build the communication, starting from that.
So you don't actually try to show them these laws of physics, the laws of chemistry, or prime numbers. You make assumptions about who the extraterrestrial being will be. And you assume that if they are able to find this object, this craft floating in space, and find the player, not the player, but the box of the record within that, then they have the science that it takes to look at it and appreciate it.
And we also think they have the motivation. If they don't care, then it doesn't really matter what we do.
Yeah.
But if we found something like this, and we looked at the spacecraft, and every part of it we could figure out. This is an antenna, this is a power source, this is a camera, and then there's this record. What the heck is this? So they know it's not an instrument. It's significantly different than anything else. And do they figure it out right away? Probably not. But if we found something like that, we wouldn't look at it for 5 minutes and give up. We'd get all our best people on it, of different disciplines. And it might take years before somebody cracked it. But there has to be the motivation of understanding it. But if you turn it around, if we found something like that, we'd be highly motivated to understand it. It would be all over the world. It's a matter of curiosity and how smart they are.
Yeah.
If they're out in space
They got to be somewhat smart.
They've got to be smarter than we are, at least.
Okay. So a question also, you have to be making some assumptions about their senses, whether they can see, feel, think. All these. I mean, you can't assume they're human. Although I suppose you have to make some assumptions that they have what it takes to be an intelligent being. What assumptions?
Well, for one thing, we know they can't be human because humans are the product of a long evolutionary history on Earth that wouldn't be repeated. That would be the most surprising thing of all if they were human. But will they have senses? Well, if they evolved on a planet, sight and sound have been evolved by many different creatures again and again over evolution because it's so useful to see if something is coming to eat you or if there's something that you can eat. Sound works that way as well. So would they have different senses? Possibly. But sound and vision have been so useful on our planet that maybe they're useful elsewhere. The other thing is that what science has learned to do is apprehend the universe in ways that we can't with our own senses. Astronomers on Mauna Kea are looking at the radio sky, the infrared sky, the ultraviolet sky, the X-ray sky. We can't perceive any of those, but we've found ways to perceive it and convert it into something we can understand. So we think that even if they don't have the same kinds of senses, we've given them some clues. For example, we've included a spectrum of the sun. And the spectrum of the sun is like, or any star.
You mean a drawing of a spectrum of the sun?
No. What astronomers do is they put the light of the sun or the light of a star through a prism and turn it into a spectrum, into a rainbow. And on that rainbow are these little dark lines, which are caused by chemicals in the atmosphere of the star that absorb some of the light, so it's a little dark line. And that's like a fingerprint. It's characteristic of what kind of star it is, and it's characteristic of what wavelengths we're looking at. And an extraterrestrial physicist, we hope, will be able to look at that and go, well, that looks like the spectrum of a star. It's this type of yellow star, and it's these wavelengths that for us is the visible spectrum. Maybe for these weird creatures, us, that's what we used.
Is this on the record or on the box?
On the record.
Itself?
Yeah.
So you're trying to give them a really full picture of what it's like down here. Yeah. Anyway, that's Jon Lomberg. He's project director of One Earth Message. The website is oneearthmessage.org. Here on ThinkTech Talks, we're talking about sending messages into space. We're not kidding. Right here from Hawaii. We'll be right back after this short break.
Hi, I'm your host on ThinkTech Asia, Bill Sharp. I look forward to you joining us each Monday between 4 and 5 o'clock when we film right here in our studio in downtown Honolulu. The show, ThinkTech Asia, focuses on contemporary events in Asia. And by Asia, we mean anything from Hawaii, south to Australia and New Zealand, west to Pakistan, and as far north as the Russian Far East. Clearly, this is one of the most economically dynamic centers of the world, and we bring you up to date on what's going on in a whole host of countries in this very vital region. We look forward to seeing you. Aloha.
Okay, we're back, we're live. We're here with Jon Lomberg, the project director for One Earth Message, oneearthmessage.org. He operates on the Big Island, and he's an illustrator and more, a scientific illustrator, astronomical illustrator, who is interested in the technology by which we would send messages into space, try to reach extraterrestrial beings. So one of the things you mentioned before to me, Jon, was the New Horizon project. And that was launched in 2006, which is 8 years ago, toward Pluto. Can you describe that for our audience?
Yeah, Pluto is the last of the traditional planets to be visited. We haven't flown by Pluto. We will next summer, but it's a long ways to Pluto, so the spacecraft was launched in 2006 and has been cruising all of this time out to that distant planet. When they launched it, I thought they would put a new version of the Voyager record on it, because this is the next spacecraft after Voyager that will leave the solar system. It doesn't happen very often. But they didn't put a message on it. And I thought, well, that was a lost opportunity. But then I thought, well, why not make the message here on Earth and send it up to the spacecraft as a digital stream and record the message onto the computer, awaiting discovery sometime in the future.
But you can be more current that way.
You can update it. With the Voyager record, once it's sent, it's gone, it's untouchable.
Yeah.
But they expect to be in contact with New Horizons for decades, perhaps even a century, because the mission doesn't end at Pluto. They're curious as to what's beyond Pluto. Can they continue making observations? Based on Voyager, they'll be in touch with it for decades. So it'll be sometime about a year after the Pluto encounter that we'll be sending up this message that we're just beginning to create right now.
You know, this reminds me of that recent news story about the satellite that was intended to actually land on an asteroid, and the satellite still works, you know, years later, and it was sleeping because it wasn't positioned properly to reach this particular asteroid. So they had to wake it up, and
Yeah.
it was waiting for them to wake it up. It's interesting how these kind of space conversations take place. It goes dormant, but it's waiting for you, and sometimes you have years of hiatus before you actually connect with it.
And in the case of New Horizons, it might be millions of years. And at that point, the plutonium is long since all dead, so it's a dead spacecraft, and maybe they'll start it up. Maybe they'll supply power and try to see if it still works.
Yeah, so interesting. So tell us more about, so, you know, I mean, I think I understand. I'll tell you what I think I understand, but then you can correct me or enhance this. So the computer is there. It can be woken up. We can send a stream of data to the computer by radio. Because it's so far away, it takes a year to get there. The computer would receive this and record it, I guess, to its drive. And then that would stand as the record that you put up there in 1977 in the Voyager project.
Yeah, the only correction I would make is that it takes about 6 hours or so, maybe more by the time we send the record up, for light to travel. And that tells you how fast light travels. I mean, it took us since 2006 to get there, but a radio message gets there in less than a day.
Okay, so
the message goes
the
up
message
quickly.
is much quicker than a year.
Right.
But you're not going to send it for a year.
And the reason we're not is that the 8 gigabytes of memory that the computer on the spacecraft has will be all filled up with pictures and other measurements and observations. The data rates at that distance are so low, and they want to make sure that they get everything, that it might take as long as a year to download those 8 gigabytes of these incredibly priceless pictures and other measurements of Pluto. It's only after that data have all been returned that we'll be sending up our message. There'll be room on the memory for it then, and we'll send it up then. And we think the message on the kind of flash memory that it's encoded on, it's very much like a little memory stick or thumb drive, which works by this arcane principle called quantum tunneling. That's
right.
how the bits are actually recorded on the memory. And there's good reason to think that our message is durable, certainly for 100,000 years. And if we build some redundancy and robustness into it, maybe for over 1 million years. And then, of course, we don't know the technology of whoever finds it. It may be that even long after that, they're somehow able to recover the information, and then their job is to try to figure it out.
So my first question on that is, why didn't they just go down to Best Buy and buy a drive with a terabyte, even a mirror drive with a terabyte of information?
Well, you know, the spacecraft was launched in 2006, but it was being designed and built around the year 2000. So the technology on the spacecraft is already like 15 years behind where we were, but that's just inevitable. Computers progress so quickly that you have to freeze the design of a spacecraft. A good, you know...
You can't chase it all the time.
Right.
Yeah. The other question that comes to mind is, you know, we talked before about time capsules and the like. Well, assuming that the Earth lasts 1 million years, assuming there are actual people around on the Earth and we don't blow each other up in the next 1 million years, somebody has got to know about this. So somebody has to be aware of what this is and how it works. Where is that being written down?
It's a good question. You know, will we survive that long? Will our culture survive that long? All I can say is I believe that missions like the Voyager will remain in human memory as long as any history has remained. In fact, in the long term, what the 20th century may be most remembered for is the discovery of atomic energy and the first steps into space. All the politics, all the wars, that'll be as much interest to them as for us some war that Charlemagne fought was. Yeah, it's in history, but we don't really care about it.
Yeah, sure.
But these things, the first time that people stepped on the moon, is something that's like the first time life crawled out onto the land. It's an evolutionary milestone. And the first time we send messages out of the solar system, that's also an evolutionary milestone. So I think these things will stay in human memory for a very long time.
Yeah, okay, I hope so. But neither you nor I will have any clue about what happens. So we have a video that you brought down, and we're ready to play that now, and this will help shape the rest of our discussion. It's a few minutes long. Let's play the video of I guess it's the New Horizon Project?
One Earth Message Project.
One Earth Message Project. Here we go.
We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
Hi, I'm Jon Lomberg, and I've got some great news. Humanity is sending another spacecraft out of the solar system, only the 5th. It's called New Horizons, and it'll fly by Pluto in 2015 and then on out into the galaxy.
One Earth.
Una tierra.
Yksi maapallo.
Our Pioneer and Voyager spacecraft carry our greetings to the stars. The New Horizons spacecraft could contain an even richer digital greeting. The message would present a self-portrait of Earth to any space-traveling beings who might someday find the New Horizons craft adrift in space. Our international team will guide the message creation process and will beam our digital message to the New Horizons onboard computer. We are putting out a call for participation from around the globe. So, who will speak for Earth? You will. Whatever your language is, and wherever you are on this planet, you will. We will gather all of your submissions on our website, and everyone will have a chance to vote and select which materials make the journey beyond Pluto and out into the stars.
Surely the act of working together to represent not only the people of the world, but the other beings with which we share this planet is in itself a thing worth doing. So we ask for your support. Let's make a message and send it to the stars.
We need your help. The New Horizons mission is not paying for the project, so we must raise the funds ourselves. Please help our campaign and join us in this incredible opportunity to connect with the cosmos in a very personal way.
Okay, wow, that's really interesting. But one thing I get out of that is that the message, the actual message that you're going to upload to the computer on what is it, New Horizon, hasn't actually been written yet.
No, and to me, that's the most interesting part of it. I've had my chance on Voyager to decide what pictures and what music should be sent. This time it'll be the people of Earth who decide. Anybody who cares enough to get on the internet, submit a picture, vote on the pictures they like, and we'll keep a kind of a running total of what are the areas of content people think are important, and specifically what contents do they want to send. So I don't know what the final message will be. All I know is that it will reflect what people around the world will want to say.
But how do you sample their thoughts? How do you gather their thoughts? How do you compile, you know, the data to put on the computer?
Well, we're going to build a part of our website where the whole process is explained. People can sign up, they can submit their pictures, they can vote on other pictures, and they can give us their opinions on some of the other major questions that we have to settle.
In the end, you'll make the decisions, though.
In the end, NASA will make the decision. I mean, the final message has to be approved by NASA. So what I would imagine is that we'll have some finalists for every picture category, and we'll probably divide the pictures up into categories, because if you ask people what should we send, I think everybody would come up with a similar list, right? Mm-hmm. We should send children and families and animals and vehicles and homes and landscapes and, you know.
The points of our society.
Right, the different things that are important. If you never saw Earth and you never saw humans and you could only send up a limited number of pictures, what would you send? So which pictures will be is going to be determined by the people who participate on the website. I think we put the website address up. We haven't opened the submission process yet, but if people sign up at the website, they'll be notified when it's time to start sending in your pictures.
Oh, that's very interesting. And then this trip, the New Horizons trip, is different from Voyager in the sense that you can do it again. You can sort of scrub that disk and then send up a new message.
That's right. They expect to be in touch with New Horizons for decades, maybe as long as a century, which means that children who submit pictures, and we want to have a section of the message that's pictures from children selected by children, they'll be as old as we are while the spacecraft is still in contact. And they may say, well, that was a good message for 2016, but now in 2050, let's add this, that, and the other thing that we didn't have, and let's take out those things that's too dated now. So it's a kind of a malleable message. With the Voyager record, once it was sent, it was gone. You can't change it. But this one, we can improve it, expand on it, edit it for a long time.
What's interesting to me is that if you had your druthers, you would do installments. you would say message number 1, you know, is in, say, 2016, message number 2, say 10 years later, and so forth. But there's not enough room to do installments, right?
No, there actually is quite a bit of room on the memory, and the farther the mission goes, the less it will need its memory. So what I'm hoping...
Be more efficient.
Or there'll just be more room. They need the 8 gigs of memory for the
operational
Pluto encounter.
things, yeah, okay.
But once they're done that, they may be willing to have the original message, but put up another one, and as you say, and then another one.
That would be very interesting for whoever looks at this to see, you know, the delta factor, how quickly things change, yeah, and sort of get a trajectory on the way humankind is evolving. That's really interesting.
Yeah. One other thing I'd like to say about it that was a surprise. To persuade NASA that this was a good idea, we put a petition online, and we got over 10,000 signatures from 140 countries. But what was remarkable is that 10% of them came from Pacific Islands, who represent less than 1% of the world's population.
Why is that?
Well, we struck some kind of nerve. Yes, we got a lot of people from Guam and Fiji and, you know, the larger islands, but we also got from Northern Marianas and a place called NIUE, Niue. Ever hear of it? I'd never heard of it. It's an island, it's an independent state, 1,300 people. We got 40 signatures from that island. That's like 30 million Americans. And one of our advisors is in Tonga and said, well, you know, this resonates with Pacific people because all the people's history started with a canoe disappearing over the horizon. And so for our New Horizons canoe to be disappearing, maybe to find some other island someday, it strikes a nerve. I think it's very resonant with people of the Pacific, and it's a global project, but it's also a Hawaii project. It originated on the Big Island, and we want to make sure that our communities in Hawaii are very well represented.
Is it possible that these Pacific Islands, you can see the stars, and you have a greater awareness of astronomy and planets out there?
I think so. I think that the price we've paid for our technology for most Americans is that we don't see the stars anymore, but most Pacific Islanders do. And not only do they use them for their beauty, but they use them for their calendar, the way we do with the Makahiki here in Hawaii, and of course for wayfinding. If you don't know the stars really well, you can't colonize the Pacific, but these people did.
Yeah, so they're into that.
They're expert at thinking of themselves connected to the cosmos.
GPS
anyway.
or otherwise.
Yeah.
So I guess, you know, you said that it was connected to Hawaii, but I'm wondering, when you get the message together, message number 1 in 2016, are you going to send it from one of the facilities here in Hawaii, or are you going to send it from somewhere else?
The way NASA communicates with its spacecraft is with something called the Deep Space Network, which are 3 large radio telescopes spread around the world. One is in Spain, one is in California, and one is in Australia. So one of them is always pointed towards the spacecraft. And that's the message of sending information up and receiving the data down. And NASA, in the agreement that we're still finalizing with them, has agreed to send up our message from the Deep Space Network.
And what in return? I mean, is there any technology, any thought given to exactly how the extraterrestrial beings would, you know, respond after they saw our messages?
This is a time capsule, not a telegram. It's not intended to provoke a response, and if it does, it'll be so far in the future that it won't even be clear what star this thing came from. So it's more like something left in the pyramids to be found by people thousands of years later. It's probably not the best way to do interstellar communication. Radio is so much faster that these programs in what's called SETI, Search for Extraterrestrial Intelligence, are looking for radio signals from other stars. So far, we haven't found any. And these kind of message artifacts are a different approach, which were purely opportunistic. The spacecraft was going out anyway, and it seemed a shame not to put a message on it.
Mm-hmm. Now, Pluto is just a matter of convenience here. This is not about Pluto. This is about the trip to Pluto. But this New Horizons is going to go further than Pluto, right?
Right. In order to get to Pluto, you have to be going so fast that you're going to escape the sun's gravity. and just drift in space forever. Space is so thinly populated with stars that we're pretty sure New Horizons is never going to crash on another planet or anything.
It's outside the galaxy.
Well, it's
The
outside the
solar system.
in the galaxy, only to be found by somebody else traveling in the galaxy.
In the galaxy.
Yeah.
Let's take a short break. This is all spinning my head. That's Jon Lomberg, Project Director of One Earth Message, here on ThinkTech Talks, where we're talking about sending messages into space. We'll be right back.
Aloha, I'm Hunter Hevlin, host of Sustainable Hawaii here at ThinkTech Hawaii. You can tune in every week on Thursday at 2 p.m. to see interviews with sustainability professionals from around the state and even further abroad, learning about activities with water management, food security, waste management, and a whole host of other fascinating opportunities to get engaged with making a greener island. So if you're interested in making the transition from consuming individuals to communities of producers, check us out every Thursday. Aloha.
Okay, we're back, we're live. We're here with Jon Lomberg on ThinkTech Talks. I'm Jay Fidell. We're talking about sending messages into space, and you can't do that without some money. So how is this organized, John?
Well, NASA's not paying for it. This was a private initiative that we brought to NASA